And welcome back to ds380. This time we're going to be working our way through a file that's supplied. It's a step. Upload and reopen. While that's running, we will have a look at what's the plan here. Now, previously, I think, you may have seen we went through two options for plugs. These are seated plugs, as in kind of twisted in to place, and no matter whether we have hard plug in softer material like this steel plug in bronze or a softer plug in harder backer bronze and steel, we end up with the same result. We want C or F. We want the surface of the plug to be slightly inboard or inside of the outer surface, and the end, smaller end, to be proud or protruding out of the background material, the backer material. What does that mean for us? If we look at what we've got, kind of hard to see what's going on here. So the first step is to go ahead here and try and figure out what we're faced with. What are we trying to fix? So first, let's do some history. Right click on the top here, at the top level of the assembly, capture design history. You'll see a history will appear. It's usually populated at the start here with a bunch of placing bodies and putting them into place, putting them as components. See the colors correspond up here. To turn this off and on, the color, Shift N. Shift N is, it's good to see the color. You can kind of tell what components what. We'd like to see inside. There's various ways to do this. You can, for example, choose Control 4, 5, 6, 7, 8. It's not too easy. You have to align things properly. It's easier sometimes to just look right inside. We've got a tool for that, Inspect Section Analysis. It'll turn on the origin. Sometimes it's hard to pick. We're at ZX here. You can open the origin, ZX or XZ, and pick it within the browser. So just picking XZ. If it's facing the wrong way like this, flip it, say OK. Now let's see what we've got here. Let's orient it the same as the parts on the sample. We've got a taper here. We've got a lock nut or a nut, which is going to be pushing. This is at the very beginning of the tightening process, so the lock washer is not deflected yet. It's not flattened out, so it's in its as shipped shape. As we tighten this, it's going to tighten the washer against the green universe in a way. It's going to pull the taper into the hole. So essentially we have this arrangement. This is what we want. This should be inboard of the outer surface, or the tapered surface should continue past the plug. This should be sticking out. We're failing on both. We actually have a sort of worst combo of both. It's this one right here, E. This is no good. It's not bad, ultra bad, but it's not good. So we want to get to this. One thing we're going to do is remodel to match our expectation or our hope, but without moving too much, so not a lot of rework. Gonna have a look at what Orlov has given us. This is it as modeled right now. Kind of E. You can see it's tight around the back here. We're gonna go ahead and transfer it all the way down to D. So we're gonna fix. It's kind of hard to see, but this taper is fixed here, and we're gonna have a recess built. Cut into essentially the material over here, which will give us CF. Perfect. So just keep this in mind. That's what we're after. Let's go back to that orientation. So we're going to cut back this first, make a recess. That's the plan. Leave everything else as is. So, got the history turned on, ready to go. Step one. If you hover over something, it'll usually, or click it, it'll show you what it is in the browser. So in this case, it's obviously the shaft. We can hide the shaft. Unselect. Now, before we get started, one problem we have right now is steps come in unlocked. Pull them around. That's not great. So what I'm going to do here is lock something into the universe, this guy, ground. So right click on that, ground to parent. That'll be to the top. We'll be able to pull that. From here on, we can select all of these guys, just with a shift select, and create a rigid group. Include child components, that's all fine. Say OK. Now we can't pull anything. Just a small event, just so we don't accidentally pull things. So you can see it in history. And it, well, kind of hides itself. Rigid group 1. You can rename that if you wish. For us, it doesn't matter. Nice. Let's do that thing we were doing before, hide the shaft. And we can work away, like for example, we could work inside the ground, but let's do it all at the top level. To go back to the top level, hit the radio button. Easy to begin with. Select that face, press delete. Just that easy. Turn the shaft back on, we can see what we've got. Nice. So we're kind of looking good here. So that's perfect. So the top of our taper is now below the surface. Let's see if we've got that right. That's what we've got here. Perfect. Over to this part. Now, eventually we're going to have to go ahead here and cut something. You could go through a bunch of different variations without having to do a sketch, but let's do a sketch. Staying at the top level, sketch. I'm going to pick this face here. It's hard to see. So let's open up our origin here. I'm at the front, which is ZX, or XZ. Sketch becomes active, we get a different ribbon at the top. Move around to the front. We want to recess in here somewhere. So just, like it'd be nice if we knew where this was. Now it's not SolidWorks where we get these crazy excessive constraints everywhere. But what I do want to know is where this edge here crosses out of the plane of our sketch. One thing we can do is do a search or a shortcut for maybe intersect. That looks interesting. Let's try that. Oh, lost it. Geometry. There's filters and stuff. Link, you want to turn that, if it moves, it goes with it. Oh, good. So it's only where it crosses, there's two. Perfect. Let's go around to look at. Zoom in a bit. Just using the middle mouse button, and then the middle mouse, push down the middle mouse button to drag. I'm going to do this old school SolidWorks style, so we'll do it in two features here. We'll do a sketch and then a fillet. Now, this is the usual column approach. I'm going to do a test first, set up my structures, and then nail down the dimensions. So I'll just finish the sketch. Let's do a cut. Start with a revolve. There's only one thing active, so it's assuming that's the sketch. Axis, anything circular, conical. Let's use the part itself. You can see here it's going to cut. Oh no, it's going to cut both. Don't want to cut the shaft. There's two ways to do this. You can either go down here and turn off the shaft. You'll see it won't cut it. Another way is actually just to hide the shaft in the browser. It's up to you. It comes out to the same event. The feature doesn't change if you do one or the other. Let's turn it off, make sure we're not cutting the shaft. So the preview looks good. Say OK. Nice. Next thing, that sketch is visible. There it is in the browser. Open up. If you want, you can see it's not fully constrained, as we know. Slow double click, call it profile. And maybe cut. There's an option for us here. We can either put a fillet on this sketch itself, which will of course change the shape of the cut, or old school SolidWorks style, we can also do a fillet. Fillet is maybe more obvious in our history. So if you hover over fillet, you can see a demo, and the shortcut is F. Just drag it, you'll get a little preview. Again, we know we know flow lines, and the bigger the better. Like we can't go too crazy, which we could, but it won't crash. But like if we go too far, we just get this sort of hard to machine type shape. We want some edges. So let's make sure we get that. Looks okay. About 1. Looks good. Say okay. Our part's kind of done, but we're not looking too good. One thing that I would like to do is start to get the dimensions sorted. Now, if we're careful, and we have been, one of the big advantages of all this is that our sketch is still visible. If your sketch is not visible, just turn it on. One thing we can do, which is fab, is we can just drag it around. And we'll get like a fairly live preview. There's a problem here. We're outboard of the washer. So we need to be inboard. And one thing to keep in mind is eventually this fastener here, or sorry, this nut is going to push down and squeeze. We would like this recess here to be quite a bit smaller, as small as we can, to give this nut some good backup material. So I'm actually going to pull it quite far down. Notice what happens to our fillet though. So you don't want to make it too small, like so if we go this small, our fillet kind of gets eaten. If you're wanting to say, okay, well, I don't like this, I'd like to be able to adjust this fillet here without going into the feature. So a little extra bit of Fusion here. Do a search for our shortcut for preferences, no, parameters, look for change parameters. A window will open. You can pull that stuff around behind. Keep an eye on this guy. So open up the part, you can shift it around a bit. There's that fillet we did. There's its value. Tangency, ignore that. Right now we're looking for the size. If you press, say, 0.5, you press tab on the keyboard. It'll update on the design pane, you'll be able to see what's going on. So, say 0.2. So this gives us a chance to kind of interact with things without having to open the feature. So I'm down to 0.2. Get a full fillet here. So we're seeing both edges of the fillet, that's probably better. And it's looking not too bad. One thing that we're happy with is now that we've got this set up, we can go in here and now adjust by right-clicking on it, the sketch, edit sketch. So just right-click on the sketch lines themselves, and we can go in here and now put some dimensions. We need a center line. Snap to the origin. Say OK. I'm gonna click escape once to get out of the tool. Click once, turn it to a center line. Notice the end is unconstrained. It's not a big deal, but I'd like to make it all constrained, so I'm gonna lock it vertically to this point that we already have from the ground part. That's fine. That's looking good. So now that we have a center line, we can now do dimensions to that. Go out here so we can see it. 19 is close to 20. Now let's make sure that we're not going too far here. The advantage of some of these dimension lines is it shows you where it is on the nut. It's not too bad, it's not too great. Let's try 19. It's getting close to the taper here. Let's do another dimension where we're using still active, D. Right now we're at 4. Let's go to 4 and a bit, so let's try 4. 3. Oh, 3 is the depth, so we can't use that. 4, maybe. Let's see how that goes. Finish the sketch. Our sketch has went fully defined. Perfect. We can't move it. One way to change it now, even though we can't drag the undefined lines, we can now show dimensions. Drag them around a bit. So now if we want, let's say for example, well, 4 looks okay. Right, so we're looking okay. We've got good, if it's perfect, which we hope it is, we're going to get good gap here. We've got some nice relief, but we've also got a good amount of material to take the load from the stuff that's going to be clamping shut on this guy. Again, there's lots of other arguments here. You could argue that this nut is too small. We will just leave that as is. There's our final result. So what we've done here is we have adjusted, put it into the same orientation, sorry. We've adjusted our taper to match our corrected thing. We've matched up to D, and we're also conforming to CF in figure 152. That's good. Everybody's happy. And we've got some minor rework here that's to be done, but nothing ultra serious. In fact, simplified the machining of the back part and a little bit of minimal recess making at the front. That's it for me. Thanks for watching, and over to you.